السلام عليكم ورحمة الله وبركاته. أهلا بكم أبنائي وبناتي طلاب الصف الثاني الثانوي. مع تحياتي من فريق منصة البث المباشر مستر حسام حسن. تحياتي لكم. نبدأ النهاردة إن شاء الله في الحلقات الخاصة بالquestions والحل. هناخد النهاردة مع بعض حاجة اسمها المولر فوليوم اوف جازز. مولر فوليوم اوف جازز، فطبعا احنا في الجزئيات اللي احنا اخدنا قبل كده اللي هو بنتكلم عن النمبر اوف مولز او how can calculate number of moles, how can you calculate molar mass, وcalculations number of particles. النهارده هناخد برضو حاجة اسمها المولر volume gases او how many liters of one mole of any gas. Under how gases behave under different conditions, we have two conditions, STB and RTB. STB is a standard temperature and pressure. Temperature equals 0 degree centigrade, and room temperatures RTB 25 degrees centigrade, and the pressure is constant in the two sides equal to 180 m. The fundamentals of the concentrations of this, for this volume of chemistry. These presentations explore Avogadro's law, molar volumes, calculations, and chemical reactions involving these gases. Avogadro's discovers its values of number of particles in last sessions. I studied this before, equal to 6.02 times 10 power 23 particles in each one mole of any substance. Now we studied another things about gases. How many volume, how many liters in each one mole of any gases equal 22.4 liters at STB or 24 liter at RTB. So this Avogadro's law states that one mole of any gas occupy the same volume under the same condition of pressure. This law of foundations of Avogadro's state that this important things to study this law. We know any one mole of any gas at STB equal to 22.4 liter at STB condition. You can read that. Avogadro's law says that one mole of any gas occupy the same volume under the same conditions of pressures and temperature. This revelatory principles reveals that the volume of a gas depends only on the number of molecules present, not on the type of gas itself. It depends the type of gas. No, any gas have the same volume. Any gas have the same volume. It means that whether you have hydrogen, oxygen, nitrogen, or any gas like chlorine and HCl gas, any gas you have one mole equal to 22.4 liter in each gas at STB. This foundation allows us, and this law allows to make precise calculations and predictions about gas behave. Standard condition STB and RTB, I explain you now what is the difference between them and repeat this again in this slides. STB standard temperature and pressures. Temperatures equal to 0 degree centigrade means 273 Kelvin. Pressure equal to 180 m, 760 millimeter mercury. Its molar volume equal to 22.4 liters. These are classic standards conditions used in the most chemical calculations and laboratory measurements. We have RTB, room temperatures, pressures, temperatures 25 degree, 298 Kelvin. Pressure 180 m, and molar volume equal to 24 liters. This condition reflects typically laboratory environments and are increasingly used in modern chemistry. This differentiates between in molar volume between STB and RTB is due to the temperatures increases at 25 degrees. This causes the gas molecules to move faster and occupy more space, so the volume increases too by increasing the temperatures of this gas. We have now, why does temperatures affect the volume? You studied physics and you know the relations between temperature and volumes. By increasing temperatures, the spaces between the particles of any gas increases by absorbs this heat, and this heat is converted into kinetic energy. This is kinetic energy helps the gases to take another places, and this and these particles, the spaces between them increase too. When temperatures increases, gas molecules gain kinetic energy, okay, and move faster. This increased molecular motions called the gas to expanding. This is expand to expands and occupy a larger volumes according to gas law. At constant pressures, volume is directly proportional to temperatures. At STP 0 degrees centigrade and pressure is a constant, 1 mole occupy 22.4 liters for each mole. When we increase the temperatures to 25, so the volume equal 24 liters per 1 moles. Volume expands to approximately 24. This is 1.6 liter difference represents the about 70 percentage increase in the volumes due to the temperature rise. We have nitrogen and hydrogen and another gases. It's gas occupy a definite or a fixed number of space equal 22.4 liter at STB or 24 liters at RTB. Like hydrogen, like nitrogen, like oxygen, we have the smaller mass of hydrogen equal 2 gram per mole. This is 1 mole occupy 22.4 liters at STB, occupying to 24 liter at RTB, contains 6.02 times 10 power 23 molecules, and the same as nitrogen and the same of oxygen. The same if the number of moles equals. Okay, okay. These values depends on number of moles, not in the mass or molar mass. Molar mass, just 1 mole. If you change the number of moles, so the volume changes and the mass changes and the number of particles changes too. Same volumes, same number of molecules. How can you detect that? Because number of moles, when increase, the number of particles increase too. By increasing number of moles, number volume of gas increase too. So if we have types, two different type of gases have the same volume, so the same number of moles. If the number of moles are the same, so the number of particles is the same. But number of atoms not the same, because the components of this gas difference from the components of this gas. If these gases are the same number of atoms, so they are the same number of atoms. Okay, the same volume of any gas at STB contains the same number of molecules. This is since Avogadro's law, whichever you measure 22.4 liters of oxygen, nitrogen, hydrogen, or carbon dioxide at STB, each sample each sample will contains exactly 6.02 times 10 power 23 molecules in 1 mole of these gases. This principle independence on the gas's molecular weights, chemical properties, or physical properties. It depends solely in the number of particles present of any gas. Now we discuss the comprehensive comparisons between these tables. We have molar mass 32 grams per mole, 28 gram per mole, 2 gram per mole for this is oxygen, this is nitrogen, this is hydrogen gas. Okay, now we have number of particles the same, we have volume the same at RTB, we have volume the same at STB. The same volume, the same number of particles, the same, no, not the same molar mass. The differentiations between them is molar mass is different between them. Okay. Now we can discuss another things about STB condition and RTB conditions. Given atomic masses of carbon equal 12, hydrogen equal to 1 gram, calculate the volume occupied in 1.6 gram of methane CH4 at STB and RTB. So you must know the number of moles. If you know them, if you can to calculate number of moles, so you can to convert into volume of gas. Okay, you can calculate molar mass firstly, and you can divide it 1.6 gram into 44 for carbon dioxide, so you calculate number of moles calculated, and you can multiply number of moles in 22.4 at STB and 22.4 and 24 at RTB. So calculated volumes we have equal to 44 the molar mass of carbon, no, I'm sorry, not 44, equal 16, this is 12, and this is 4 times 1, so number equal 16 gram per mole. You divided this number of 1.6 into this gas. We have 1.6 gram of methane. You can to divide it 1.6 to 16, equal to 0.1. There is 1.1, it is the number of mole. You can to multiply 0.1 into 22.4 at STB and 24 at RTB. So the results is 2.24 and 2.4. Now, application of balanced chemical equations. Balanced simple equations are powerful tools that allow us to calculate and determine multiple aspects of chemical reactions. Understanding how to use these equations is essentials for quantitative chemistry. Now, how can you balance any equations? You must the number in the initials or the reactants equal the number of atoms in the products. Mass of substances calculated reactions in these reactions and the reactants and the products masses and number of moles determines mole relationship. Number 3, number of particles, find the molecules quantity. Number 4, volume of gases calculated by various conditions, and we have to teach limiting reactions, identify what reactions limit. This is 5 things about application of balanced equation or balanced chemical equation. Number 1, the balanced equation. What the meaning of balanced equation? Balanced equation, number of moles of any atoms in the reactant must equal number of moles of the or number of atoms of reactants equal to the number of atoms of the products. Now we can to balance these equations by and another atom. This equation shows that oxygen and hydrogen equals to H2O forming H2O. 2 moles of water decomposes producing 2 mole of hydrogen gas and 1 mole of hydrogen of oxygen gas. This is atomic mass equal to 16 grams in the two sites. We can to make electrolysis number while calculating water moles. Question: how many moles of water are needed to produce 2.5 moles of oxygen? Identify this ratio from this equation to H2O forming O2. 2 moles of H2O produce 1 mole of H2O. Okay, what you need? I need how many moles of waters H2O needed to produce 2.5. You have 2 equal to 1. You need 2.5 moles of oxygen. 2 moles equal 1. So 2.5 moles equal what? This is x unknown value. This is answer equal to 2.5 times 2 over 1. So the number of water moles needed equal to 5 moles from this water from this reaction. Mass of water needed. This is have the same equation. What mass of water is needed to produce 2 grams of hydrogen? You repeat the same steps, but here you must need mass or molar mass. It's final here. Molar mass of H2O equal to 80. 1 mole is 18 gram per mole. Finals, we have the step 1. Molar mass of H2 is 2 grams. Molar mass equal to 2 moles of water is equal to 18. Now you can divide this number of moles equal to gram of hydrogen is produced. Number of oxygen molecules. This is another way to teach us. Number 1, identify the mole ratio. Now, how many oxygen molecules are produced from the electrolysis of 1 mole of water, H2O? H2O, 2 H2O gives oxygen, O2, 1 O2. H2O2 equal to 1 O2. 2 moles. When you make electrolysis of 2 mole H2O, the number of mole produced is 1 mole. Okay, now you have how many moles molecules are produced of 1 mole. Okay, this is half moles. Half moles. 2 moles produce 1 mole. So 1 mole will produce half moles. This is the final answer of this reaction. What the meaning of Avogadro's law? We understand before. This law depends on number of moles of gas to know the number of particles or number of or the volume of gas at STP or RTP. This is dependence of the number of moles. Now we have this questions. 1 mole of any gas occupy 22.4 liters. Which statements best explain why this is true according to Avogadro's law? A, B, C, D. A, the volume depends on the type of gas. Not correct. This is false. Okay. Number B, equal volume of gases contains equal masses. Not correct. Equal volume of gases contains equal number of, right, this is true. Equal number of molecules and the same temperature and pressure. This is true, which is the true, and this is correct answer. It is the correct answer. Okay. A sample of gas occupy 44.8 liter at standard temperature and pressure. Which conclusions can you draw about the amount of substance present? Number one, containing 1 moles of gas, it contains 2 moles of gas, it contains 0.5 moles of gas, it contains 4 moles of gas. So the correct answer is B. Because we have how many sample of gas occupied 44.8. You will divide 44.8 to 22.4. You have this number is 2 moles. If you divided 44.8 to 22.4, the answer is 2 moles. So it contains 2 moles of this gas. Apply the law of Avogadro's law. Which factor primary, which factor primarily causes the molar volumes to increase from 22.4 at STB to approximately 24? Okay, it increased temperature. I explain it's increased temperature. It is a true answer. Our correct answer is increasing temperature. Uh, this is question. We have two seals contains each holds 1 moles of different gases at STB, which property will be identical for both containers. A, mass of the gas, volume of the gas, density of the gas, molecular weight of the gas. Okay, the volume was accurate or correct answer. If the molar volume at STB is 22.4 liter, predicts the volume occupies by 3 moles of gas at RTB at 25 degrees. Explanations here, the correct answer is B. Because A, this is number is 67.2 liters, 72.70 liters, 66 liters, 60 liters. Okay, you multiply 3 times 24. Multiply 3 times 24 equal to 72 liters, because in rise temperatures at room temperature. H2O plus O2 reduced to H2O and vice versa. What is this decomposes? Reactions show 2 moles of hydrogen peroxide decomposes, producing 2 moles of water and 1 mole of oxygen gas. This oxygen gas here, and the oxygen gas molar mass of H2O2 34 34.H2O2 34 gram per mole. Molar mass of oxygen equal to 32 gram per mole. Now we can conclude that H2O2 mass of oxygen produced, we know that if you have 68 gram of H2O decomposes completely, how many grams of oxygen are produced? How many grams of oxygen are produced? Okay, firstly you must calculated 68 and convert it into number of moles. You must know H2O2 equal to 2 times 1, 2 times 16, 32 plus 2, 34. Okay, you must divide it 68 into 34. Now number of moles of H2O2 equal to moles, because it decomposes of oxygen produce. Your 2 moles of H2O equal to 1, or produce 1 mole of oxygen. 1 mole of oxygen. Now you have 2 moles, so number of moles of oxygen equal to 1 mole equals 32 gram per mole. This is the correct answer, is 32. Correct answer is 32. How many molecules? I want calculate number of molecules. How many molecules of oxygen are formed when 51 grams of H2O2 decomposes? Decomposes. We have four choices. These numbers to know the correct answer, you must calculate number of moles from 51 of H2O2, which produce 1 mole to H2O2 produce 1 mole of O2. 2 moles equal to moles. Now we have say 51 gram of H2O2. You must divide 51 to 34. Now you have approximately 1.5 moles. You have 1.5 moles, 2 moles produce 1 mole, so 1.5 produce 1.5 over 2, so equals 0.75 moles. To know the number of particles, you must multiply into 6.02 times 10 power 23. Now the correct answer is D. Uh, the next, if you have 0.5 moles of oxygen is produced, 1 point, if you of 0.5 moles of oxygen is produced, how many grams of H2O were decomposed? The same relationships between we have H2O2, okay, 1 mole oxygen requires 2 mole of H2O2. 1 mole H2O2 produce 1 mole O2. Okay, I produce the production is 0.5 moles, so it is 1 mole. So it is 1 mole. This the correct answer is C, which C here. C is this number. This number equal use the molar mass. 1 mole requires 2 moles of H2O2. 0.5 moles of oxygen requires 1 mole of H2O2. Okay, calculated mass I calculated equal 34. Now we need 2 moles of oxygen for 1 mole of oxygen. Now we have 0.5 moles of oxygen produced from 1 mole of H2O2. So the number of moles of H2O2 is 0.5 moles. 1 moles, this is 68 gram needed from this H2O2. Which statements is correct about the compositions of H2O2? A, 2 moles H2O2 produce 2 moles of oxygen. Not, this is not true. Incorrect. 2 moles of H2O2 produce 1 mole. Let's try. This is correct. This is correct. Okay. To know how can you solve these questions, you must write the equations. H2O2 produce O2 plus H2O2. 1 moles, 2 moles of H2O2 produce 1 mole of H2O. The calculating the volume of oxygen produced at STB when 34 gram of H2O decomposes, you must step-by-step solution of this. Step 1, calculate number of mole of H2O2 equal 34 gram. You must divide the 34 gram into 34 gram for 1 mole of H2O2 equal to 1 mole H2O2. Apply the number of moles, produce 1 mole of oxygen, so 1 mole of H2O produce 0.5 moles of oxygen. Calculated volume equal to half moles. This half moles will multiply into 22.4 liters equal to 11.2 liters. Now, what is the meaning of limiting reactants concepts? Limiting reactant concepts, it is a substance which controls of the total reaction. These elements or compound which consumed totally in this reaction. No remains of the substance. All substances are consumed. Okay? And the products depends on this limiting reactant. If you make increasing the volume or the mass of this reactants, the product increase too. So the limiting reactant control in the products volume or product mass or product product molecules produced from any reactions. Now, limiting reactants, if you have a piece of carbon in excess amount of air, you burn a carbon, this carbon completely consumed and produce carbon dioxide. If we have a large amount of carbon dioxide is released huge amounts larger than the last equation. So the limiting reactant is the substance that it completely consumes first in chemical reaction, causing reaction to stop even if the this element or this compound is totally consumed. Now, you must have balance equations to know what is the limiting reactants of any reactions. 1 mole of hydrogen reacts 1 mole of fluorine equal 2 mole of hydrogen fluoride. 6 mole of hydrogen 6 moles of hydrogen divided 4 moles of fluorine. What's happened? This is a question. If you have 6 mole of hydrogen plus 4 mole of fluorine, now the ratio 1 to 1. Now you react 6 mole with 4 moles. These 4 moles need 4 moles only. So fluorine will totally consume. So the fluorine is the limiting reactant. 4 mole of fluorine reacts with 4 mole of hydrogen, reduce 8 moles of hydrogen fluoride, 2 moles of hydrogen remain without reaction. So fluorine is the limiting reactant because it's totally consumed in this reaction. So to know that, you must identify given amounts and you convert it by number of moles. If you have the informations by volume or mass or number of particles, you must convert it into number of moles. Okay, and you divided the reactions into two sides. First side consists of one of the reactants with the products, another side another reactants with the same products, and calculate the number of moles products from the first and number of mole of the second. And you must conclude the limiting reactant by using the least number produced from the reactant. Limiting reactants from this reaction 2H plus O2 produce 2H2O. This is the standard equation. Okay, this problem you will say determine the limiting reactants when mix 14.4 liter, you must convert into moles, okay, of oxygen gas with 24 liters of hydrogen gas at RTB under suitable conditions for action. Also calculate the excess mass of the other reactants. Okay, you must convert these numbers into number of moles to know which of them is the limiting reactants. If you know the limiting reactants, you must know then the remaining of another substance. Hydrogen 1 gram and oxygen equals 16 gram, so you can to convert it into volume, from volume to moles, from moles to mass if you have. Now, in step number 1, calculating number of each gas. Number of each gas molecules equal to 24 of each number of each 1 moles. Now you have 14 you have 14.4 liters. You must divide it into 24. This is number of moles of oxygen. And repeated some hydrogen, the equal number of moles is 1 moles of hydrogen. This is actual values in this reaction. identify limiting reactants here. The ratio of H2 with O2 is less than the ratio of oxygen 0.6. So therefore hydrogen is a limiting reactant because oxygen need hydrogen needed uh, a definite number or fixed number of oxygen, and the other is remaining from this reaction. So the limiting reaction is limiting reactants is hydrogen. uh, okay, you can to calculate the X amount of oxygen and convert into by mass. Okay, this is reaction depends on the excess amounts of moles, and you subtracts from you how many moles you need and how many moles remains. So you must convert number of moles into mass by multiply remaining of number of moles from the oxygen excess amounts. Now you can to multiply number of moles in molar mass. Now we finished our sessions today, and good hearing and good listening, and thank you for our people, and thank you. Wassalamu alaikum wa rahmatullahi wa barakatuh.